Hi class. So we're going to be talking about the key characteristics of graphs. So one of those things that we find is the domain. That is what our x values can be. The range is our resulting y values. The minimum is the lowest y value on our graph. The maximum is the highest y value on our graph. The x-intercept happens when our y value is 0, and it's when the graph crosses the x-axis. The y-intercept occurs when x equals 0, and this, I somehow switched my pen. When x equals 0, and this happens when the graph crosses the y-axis. Decreasing. This is when my y values are decreasing, but decreasing. But as a reminder, the interval where that's occurring is the interval comes from the x values or the x-axis, and increasing is where my y values are increasing. And again, we get our interval from the x-axis, which is sometimes confusing when we're writing our intervals. So let's take a look at this linear graph here. So this is a graph of a line. So this function is linear. Its domain, because my graph is going upwards forever and downwards forever, going left and right forever, my domain is all real numbers, which we can write several ways, and any of those are fine. Because my graph is going upwards and downwards forever, my range is also all real numbers. There is no min or max on this graph. There's no highest y value or highest or lowest y value. My x-intercept, I can read it right from my graph, and it looks like it's 8, 0. And the y-intercept, I can read it right from my graph, and it looks like that's 0, negative 4. And this graph is always increasing. My y values are always going up. This graph has positive slope. So we can say it's increasing for all the values on the x-axis, and it's never decreasing. So as my x is going to infinity, my y values are also going upwards to infinity. And as x is going to negative infinity, my y values are also going down. Oops, I lost my pen. Going down to negative infinity. Let's take a look at the next graph. So this is a parabola. So this is a quadratic function. And my domain is all values of x, because my graph keeps growing outwards forever and ever and ever. So to my domain for my x values, my range are my y values. And I've got all these negative y values because it goes down forever. But my y values do not go above 4. So when I write my range, it's always smallest to largest. So it's negative infinity to 4, and I'm going to put a bracket at 4. In fact, I'll make that look less messy. Let me erase that. Because this particular function, the graph exists at 4, and this coordinate is actually, it looks like negative 3, 4. So that brings me to my min or max. In this case, I have a max at negative 3, 4. My x-intercept on this one looks like it's negative 1, 0, and it looks like it's what, negative 5, 0? So negative 1, 0 and negative 5, 0. My y-intercept is down here at negative 5, or sorry, 0, 0, negative 5. And the increasing. So let me get a highlighter. So this is where my graph's values are going upwards. My y values are getting bigger and bigger and bigger. But I want to write the interval where that's occurring on the x-axis. So that's happening from negative infinity to stopping at x equals -3. So that's negative infinity to -3 on the x-axis are where my y values are increasing. And this is where my y values are decreasing. And that's happening here on my x-axis. So that's happening from -3 to positive infinity. Notice the parentheses at -3, because at -3 on one side, my values are increasing. On the other side, they're decreasing. They're not doing anything the same on both sides. So it's going to be parentheses. And then my end behavior, as my x are going to infinity, my y's are going down forever. And as x is going to negative infinity, my y's are going down forever. So let's take a look at this next one. I don't know if you remember this function or not from Algebra 1, but this would be an absolute value function. That's the V look to it, absolute value. And in this absolute value, my domain, because there's arrows on the end of this, so it's going left and right forever and ever. So my domain would be all real numbers for my x values. For my y values, they're going upwards forever, but it looks like my y values are starting at y equals 1. So remember, I write smallest to largest. So 1 to infinity would be my range. I do have a minimum. My minimum value is occurring, it looks like at 4, 1. My x-intercepts, I don't have any, so there's none. My y-intercept looks like it's occurring at 0, 5. My increasing interval, let me grab my highlighter. This is where my graph is increasing, and this is the x values where that's happening. So I'm going to write from 4 to infinity is where it's increasing. And then this is where my graph is decreasing, left to right. And this is the x interval that it's happening at. So I'm going to write that as negative infinity to 4. Notice I have parentheses at 4, no bracket. And then my end behavior, it is at the right end as x goes to infinity, my y's are going up. And on the left side, as x goes to negative infinity, my y's are also moving up. So I'm going to skip a couple pages because those are going to be practice problems for you. But I want to go to the last page and talk about the trig graphs. On the trig graphs, there are a couple things that we're not going to be doing this year. So first of all, you can cross out the interval increasing. I'm going to talk about it, but I wouldn't expect you to write the interval. We're going to talk about the interval decreasing. Again, I'm going to talk about it. And you can cross out end behavior. I'm going to talk about it, but it's not something, and then min and max. So it's a lot of stuff you're crossing out, huh? So let's first look at this graph. So on this graph, I noticed that my midline is probably this horizontal line at x equals 3. I'm sorry, at y equals 3. My horizontal lines are always y equals, I apologize. So y equals 3. And it starts at its midline. So that would be a sine graph. So this is an example of a sine graph that's up 3. So I have a sine graph, sine x plus 3. That would be what this function would be. And it goes one above and one below, so there would be no amplitude. Well, the amplitude is 1. So this is a sine graph, the sine function. My domain is all real numbers because this graph is oscillating between, it looks like 2 and 4. So my range, 2 would be the smallest number, to 4 would be the largest y, and it just kind of goes back and forth between those. Notice the brackets on both because it can be 2 and my y value can be 4. My x-intercept, I don't have one here. My y-intercept happens to be at 0, 3. That's a comma. So let's talk about my increasing intervals. If you Google this, there is an increasing interval. I say Google in case you want to learn more since I'm not going to talk about it a lot. But my graph, I'm sorry, I thought I had a highlighter. My graph does have parts where it increases. this is where my graph would be increasing, for instance. So it's more of an interval, like this occurs between two numbers. It also has a part of the graph where it's decreasing, and like there's another part over here that would be decreasing, and over here there's a part, oops, sorry, I lost my little thing. And in the classroom, I'm gonna talk a little bit more about this and like how to write it, since it's basically, it's a reoccurring increasing, decreasing interval. But I'm not going to in the video right now, but just know that it's something that you're gonna learn about next year. Same thing with decreasing. So what about end behavior? End behavior for this one, because it's always oscillating between 2 and 4, this one is oscillating between 2 and 4. It doesn't have an end behavior as far as it's going towards infinity or negative infinity or anything. It just keeps bopping back between those two numbers. So we don't really write end behavior statements like the ones you see there. So let's take a look at our cosine graph. This like sign, there is just some stuff on it that we're not really gonna worry about. So again, the max min, because it does have a max, it does have a min, they're reoccurring. So it's more of something that you write it like a reoccurring interval. Same thing with my x-intercepts. There's more than one of them. It reoccurs. It's at pi over 2, and it recurs every pi value increment after that. So we do write about it, but I'm not really going to talk about it today. We'll just say that the y-intercept, I can see it right now, is 0, 2. I'm just going to put it there. And also increasing interval and decreasing interval, we're not really going to discuss this year. So let's discuss this graph. So when I look at this graph, I have a midline right here. It happens to be the x-axis, which is y equals 0. And it looks like I have an amplitude of 2 above and 2 below, and it's starting at its max, and so that was cosine. So this is 2 cosine theta. So this function is sorry, I lost my marker. This is a cosine function. The domain is negative infinity to infinity. My range, it looks like it's going between negative 2 and 2 with brackets. Again, the max and the min, you'll talk about next year. Also, the x-intercepts, it occurs at pi over 2, just to give you a little bit of an idea. So it occurs at pi over 2. So it's every, for instance, it's every pi over 2 plus pi n. So this is pi, when you go pi units, 1/2 to 1.5, 1. So this is 1/2 pi, one way to think about it. This is 1.5 pi. So like every 1 pi, it's gonna have another x-intercept. So you write it in this way. It's like every pi over 2 plus pi n, where n can be, different numbers. But again, it's something you guys are gonna talk about it next year, so I'm not gonna spend time on it right now. And the end behavior, this is an oscillating graph. So its end behavior basically bounces between negative 2 and 2. So you don't really write it the way we did for the rest of our graphs. So this is just a little good recap of sine and cosine real quick as we get to the end of our unit, but also we get ready to start thinking about our final, and these sine and cosine type graphs could be on there. I will see you guys in class. Thank you.